Hi, and welcome to Quick Add Maths on vectors. The prerequisite to this segment is that you would have understood what is covered in Quick Math on vectors, which includes vectors having both magnitude and direction, its representation of displacement in the form of a column vector xy, its modulus being synonymous with its magnitude or length based on the Pythagoras theorem. When two vectors are added, the resultant vector is a straight line from the start of the first vector to the endpoint of the following second vector. And finally, multiplication by a scalar is a mere scaling of the vector magnitude with its direction staying the same. Here are additional key notes. Vectors are collinear when they are parallel and share at least one common point. A column vector 3, 4 can also be written as 3i plus 4j, where I is a single unit in the positive x direction, and j is a single unit in the positive y direction. A unit vector has the magnitude of one unit, for example, a fifth of 3i plus 4j. And lastly, when a vector is a displacement from the origin O, the vector PQ is the same as the vector PO plus the vector OQ, which in turn is the same as the negative of vector OP plus the vector OQ. Tutorial question 1. A vector PQ has a magnitude of 39 units and is parallel to the vector 12i minus 5j. Find the vector PQ. The given vector has a magnitude of 13. With the vector PQ having a magnitude of 39, it would be 3 times that of 12i minus 5j. This equates to 36i minus 15j. Tutorial question 2. Relative to an origin O, the position vector of A is minus 7i minus 7j, and the position vector of B is 9i plus 5j. The point C lies on AB such that the vector AC is 3 times the vector CB. Find the vector AB. With the expansion of AB being equal to AO plus OB, this will work out to AB being equal to 16i plus 12j. Next, find the unit vector in the direction of vector AB. By leveraging on Pythagoras theorem, the unit vector of AB is 1/20th of 16i plus 12j, which simplifies to a fifth of 4i plus 3j. Next, find the position vector of C. Starting with equation AC being 3 times CB, we could expand both sides, then gather OC on the left-hand side to solve for it being 5i plus 2j. Tutorial question 3. Relative to an origin O, the position vector of A is 4i minus 2j, and the position vector of B is lambda I plus 2j. The unit vector in the direction of vector AB is 0.3i plus 0.4j. Find the value of lambda. By expanding on AB, we should be able to form an equation consisting of its i's and j's. With reference to j, k can be solved as being equal to 10. Separately, with reference to its i's, lambda will solve to being 7. Tutorial question 4. Relative to an origin O, the position vectors of A, B, and C are minus 2i plus 7j, 2i minus j, and 6i plus lambda j respectively. Find the value of lambda when AC is 17. By first obtaining AC in the form of its I and j, lambda minus 7 can be obtained using Pythagoras theorem. Next, find the value of lambda when ABC is a straight line. When ABC is a straight line, the vector AB is equal to k of the vector AC. By expanding on these two vectors and then referencing to I individually, we could solve for k being 0.5, and when referencing to j individually, lambda works out to being -9. Next, find the value of lambda when ABC is a right angle. When ABC is a right angle, k of vector BC will be equal to -8i minus 4j. We will then expand on the equation, and with reference to I, solve for k being equal to -2, and separately with reference to j to solve for lambda being equal to 1. It is worth noting that vector geometry is often a pictorial view of multiple projections and defined parameters. The attached is one example where its r can be defined as the midpoint of OA, and the vector OP is defined as being equal to 3 times that of the vector OB. Then we are asked to solve the other relationships. As velocity is a vector, the parameters of velocity and speed often appears in questions pertaining to vectors. As an example, when an object travels from A to B in the time of 2 seconds, with vector AB being equal to 8i minus 6j, its velocity will be equal to 8i minus 6j over 2, whilst its speed is the magnitude of the velocity. Having covered the basics, do latch on to the video on AthMath EQ on vectors to get familiarized with exam questions related to this topic. That's all for quick AthMath on vectors. If you found this beneficial, do seek out our other videos under the KT Tutorial channel.